Welcome to Cosmic Compass, the channel where we journey together through the wonders of space astronomy and the stories that shaped our exploration of the cosmos. Here we uncover not just the science, but the human and sometimes non-human stories that made it possible. Today, let's step back in time to the dawn of human spaceflight, when the courage of one unlikely pioneer, a chimpanzee named Ham, changed the future of exploration forever. Before humans dared to risk their lives beyond Earth, another creature paved the way. A small chimpanzee named Ham became the first hominid to venture into space. His mission was perilous, the odds of survival uncertain, and yet his story became one of the most important stepping stones for human spaceflight. So, what exactly happened to Ham? Did he survive the crushing G-forces, the dangerous re-entry, and the unpredictable failures of early rockets? Today, let's journey back to a time when the fate of space exploration rested on the shoulders of one cheerful chimp. This is Cosmic Compass. Together, we will explore how Ham's mission unfolded, what it meant for the United States in the midst of the space race, and how this remarkable flight shaped the future of humanity in space. To understand Ham's role, we need to look at the tense backdrop of the late 1950s. This was the space race between the United States and the Soviet Union, a contest of science, technology, and power. When the Soviets launched Sputnik 1 in 1957, the first artificial satellite, the world was stunned. For Americans, it was a blow to national pride and a reminder that their rival was pulling ahead. At that time, space projects in the United States were managed not by NASA, since NASA had not yet been established, but by the US military. Rockets were still primitive. Small vehicles like the Aero B-3, only 8 meters tall, carried mice and monkeys to altitudes of around 60 kilometers. These animals experienced short bursts of weightlessness, then returned to Earth. They often looked bewildered, but most survived without serious harm. Why monkeys? Because their physiology resembled ours. If a monkey could survive acceleration, weightlessness and re-entry, then perhaps a human could too. In 1959, 2 monkeys, Miss Abel and Miss Baker, were launched aboard a Jupiter rocket, reaching an altitude of 570 kilometers and speeds of 16,000 kilometers per hour. The mission was a technical success, but tragedy struck when Abel died a few days later from surgical complications. Baker lived and was honoured as a pioneer of biological spaceflight. Even today, visitors still place bananas on her grave. These experiments demonstrated the risks, but also the possibilities. Soon after NASA was founded, taking over responsibility for human spaceflight under Project Mercury. The stakes were high. If America wanted to compete, it needed to prove that not only satellites, but living beings could be sent safely into space. By 1961, NASA believed it was ready to test a hominid, a great ape, capable of performing tasks aboard the Mercury-Redstone rocket. Unlike earlier small rockets, this 25-meter launcher was big enough to carry a human capsule. The plan was not orbital, it would be a suborbital flight, reaching space, but falling back to Earth without circling the planet. Still, the risk was immense. Why use a chimpanzee instead of a human right away? Because this time the passenger was not just along for the ride. NASA wanted to see whether a living being could still perform complex tasks under stress, something critical for future astronauts. If radio contact was lost, astronauts would need to operate controls themselves. From a group of 40 chimpanzee candidates, one stood out. Known only as number 65, he was healthy, quick to learn, and perhaps most importantly, displayed a happy, calm temperament. Trainers described him as cooperative and even cheerful qualities that made him more resilient under stress. Later, he would be given the name Ham, after the Hominid Aerospace Medical Center where he was trained. Ham was conditioned through a simple but revealing task. Whenever a blue light appeared, he had 5 seconds to pull a lever. Success earned him a banana pellet. Failure resulted in a mild shock to his foot. This test measured reaction speed and discipline skills essential to proving that humans could work in space. To protect him, Ham was fitted into a miniature life support capsule, a kind of spacesuit, with its own oxygen temperature regulation and medical sensors. Through it, NASA could monitor his heart rate, breathing, and performance. His arms were left free so he could carry out his assignments. After months of training, Ham was ready for his historic mission. On the morning of January 31st, 1961, Ham was strapped into the Mercury capsule atop a Redstone rocket at Cape Canaveral. Engineers and scientists anxiously ran through final checks. For them, this was more than just a test. It was the rehearsal for sending humans into space. The countdown ended. Engines ignited. The rocket thundered into the sky. Within seconds, however, something went wrong. The rocket's trajectory began to drift upward, climbing at a steeper angle than planned. This seemingly small deviation created massive consequences. The capsule accelerated harder and faster than expected. Ham endured crushing forces of up to 17 Gagarin, far beyond the planned limit. To put this into perspective, most humans lose consciousness around 9G without special suits or training. Ham, however, stayed conscious inside his protective capsule. Just 2.5 minutes into flight, the rocket's liquid oxygen ran out. Computers registered the emergency and the system automatically triggered an abort sequence. The capsule separated early from the failing rocket at an altitude of 250 kilometers higher than expected, but far riskier. Inside, Ham was oblivious to the crisis unfolding. Protected by his personal capsule, he continued his training routine, responding to lights and pulling levers. Remarkably, his performance was almost identical to his results on Earth. Despite violent vibrations, massive G-forces and weightlessness, Ham did his job. But new problems arose. Sensors reported that the capsule was losing pressure rapidly. Engineers feared the Chimp might suffocate. In reality, the leak was caused by a faulty valve, shaken loose during launch. Luckily, Ham's own sealed capsule kept him safe. As the capsule re-entered Earth's atmosphere, Ham experienced another brutal round of forces, this time around 14G. Without retro rockets to slow descent, the craft overshot its landing zone by 100 kilometers, splashing into the Atlantic Ocean. When the capsule hit the water, its heat shield detached, damaging the base and allowing seawater to flood inside. Airbags had deployed, but they were worn and leaking. Within minutes, the capsule began to sink. For those waiting on Earth, the silence was agonizing. No signals came for 12 long minutes. Imagine being a NASA engineer in that control room. Had the mission failed? Was Ham alive or lost beneath the waves? Finally, a beacon was detected. 27 minutes after splashdown, a search plane spotted the capsule floating precariously. Navy helicopters raced to the site. By the time they arrived, the capsule had already taken on more than 350 kilograms of water and was close to submerging. It took nearly 3 hours of effort, but eventually the capsule was hauled aboard a Navy ship. Inside, the fate of the mission, and perhaps the future of American spaceflight, waited to be revealed. When the capsule door opened, Ham looked out at his rescuers. He was alive. Not only alive, but cheerful, seemingly unaware of the danger he had faced. His only injury was a small bruise on his nose. Against all odds, Ham had survived. His mission proved that a living being could withstand the violent forces of spaceflight, carry out tasks under stress, and return safely. This success gave NASA the confidence to move forward. Just 3 months later, astronaut Alan Shepard became the first American in space aboard Freedom 7, another Mercury-Redstone rocket. Although his flight was short and suborbital, it marked the beginning of human spaceflight for the United States. The Soviet Union, however, achieved an even greater milestone. In April 1961, Yuri Gagarin orbited Earth aboard Vostok 1, becoming the first human in history to do so. The Soviets had won that round of the space race. Yet Ham's contribution was undeniable. Without his mission, Shepard's flight may never have been attempted so soon. Ham himself retired from duty. He lived out his life first at the National Zoo in Washington, D.C., and later at a zoo in North Carolina. He became a symbol of sacrifice, courage, and scientific progress. When he died in 1983 at the age of 26, his remains were honoured at the International Space Hall of Fame in New Mexico. His skeleton was preserved for scientific study, but his story belongs to history. Today we still feel the legacy of Ham's mission. Every astronaut who boards the International Space Station follows in the footsteps of those early pioneers animals who braved the unknown before us. And as new space races emerge, whether to return to the moon or reach Mars, we are reminded that the path forward was built on the efforts of unlikely heroes like Ham. So there we have it, the story of Ham, the chimpanzee, who beat humans to space. His flight was not smooth. In fact, nearly everything went wrong. Yet he returned safely, proving that survival and even productivity was possible beyond Earth. Ham may never have understood what he accomplished, but his mission marked a turning point in human history. From that moment, the dream of sending people into space was no longer just theory, it was reality. As we look up at the stars, let's remember the unlikely astronaut who got there first, a small chimpanzee full of energy and resilience who opened the door for humanity's journey to the cosmos. Thank you for watching Cosmic Compass. If you enjoyed this story, consider joining us again as we explore more of the mysteries and marvels of the universe. Until next time, keep your eyes on the skies. You've been watching Cosmic Compass, where together we navigate the vastness of space one story at a time. If you enjoyed this video, don't forget to subscribe, leave a comment, and share it with others who love exploring the universe. Your support helps us bring more cosmic stories to life. Until we meet again, let's keep looking up, keep wondering, and keep reaching for the stars.